So this is the last part of Chapter 0. So this one is going to be about data, so scientific data and how it's presented. So there are two different terms that we talk about when we talk about how good the data is. So first up you have accuracy. So accuracy is a description of how close a measurement is to the true value of the quantity measured. Oftentimes, with accuracy, the only time you can actually test it is basically as a test. So there's one thing that I always do with measuring when we're using pipettes, which we won't do in this class because they're super expensive, but when you have a pipette, it's usually picking up small amounts of liquid, and so we do this accuracy test just to make sure that everyone is using the pipettes correctly, and it's just picking up specific amounts of water and weighing it. So how close you get to the actual measurement of the weight of the water that it should be determines how accurate you are. So easy way to kind of think about this is by using this diagram here that shows basically a target. So I would say archery in this case. So here you can see that only one arrow hit the center of the target. So one arrow hit the bullseye, which is where you want to be hitting. Okay, and then you've got a scattering of other arrows around. So this one would be low accuracy, okay, because most of your arrows didn't hit the bullseye, right? And then when you move over here, right, so we're still not hitting the bullseye. You do have all of your arrows grouped now, but they're still not at the right measurement, okay? And then when we get down here, all right, so most of them are grouped around the bullseye. More than half of them are actually hitting some part of the bullseye, so that is still considered relatively accurate because so many of those values are right on the bullseye or right around it. Okay, and then when we get over here, you have all of your arrows grouped right in the center of the bullseye, so that is very accurate. You also have precision. So precision is how exact the measurement is. Now with precision, you have to have more than one reading, okay, more than one measurement. So here, because we have all of our arrows spread out throughout the target, this is not precise. Okay, with precision, you want all of your target or all of your arrows to hit basically in the same spot on the target, because it's repeatability. You repeat the experiment, you're getting the exact same number or very, very close to the same number. Okay, so we don't have precision on this target here. When we move over here, they aren't where they need to be, so it's not accurate, but they are all grouped together. So this is very precise. Okay, it's precise but not accurate. So you're getting a repeated result that is very, very similar. Okay, it's not the one that you should be getting, but it is at least all grouped together. Now here, again, we have all of our arrows spread out a little bit. Okay, so even though they're all right around the bullseye, and that means that they are accurate, you're still getting, like if you compare this arrow here to this one up here, it's still pretty different. Okay, so you're not hitting that same measurement every time, right? So that's why it's not precise. And then in this one, again, you do have all of your little groupings here, okay? A nice little grouping, so it is highly precise. Right? So those are the two terms that we use when we talk about how good scientific data is. Now, when you start getting into writing up lab reports or, on to scientific articles and things like that, scientists will use a lot of written reports and oral presentations to share their results. But if they're just standing up there listing off a bunch of numbers, nobody's going to understand the data, okay, because it's just not presented in a way that humans can really see the correlation between the different numbers and the results. So you have to be able to organize your data into different types of charts. So mostly we use graphs for this. It's a relatively simple way to organize data in many different forms. So you've probably used these graphs in your math classes. I hope you have. So line graphs are good for displaying data that changes continuously. So this is a simple version of a line graph. It's actually a curved one. Okay, as you can see, when you get down here, it curves a little bit. So it's not a perfect line graph, but it has that same kind of idea. So you can see you've got time increasing as you move to the right, and then volume increasing as you move up. Okay, and then you just plot the data points on the graph and then connect them with the line. So this shows independent variables versus dependent variables. All right, so we'll get into that more. Basically, independent variables just change on their own. Dependent variables change because of the independent variable. All right. So an independent variable, changes do not depend on any other variable. So in this example, it's time. Okay, whenever you have time in your experiment, that's one of the things that you're measuring, that will be your independent variable. It's pretty easy. Okay, that is one of the few that is always the independent variable. It's because you cannot change time. Okay, you can't say, all right, well, you just can't change time. It changes on its own. Okay, time, the consistency of time will not change based on any other variable. Okay, so like if you add heat to it, a second is still going to be a second. Right? If you freeze something, a second is still a second. That's what it's talking about. Independent variables are always graphed on the x-axis. Okay, so we've got a little mnemonic that's going to help us remember that here in a second. Dependent variables are the ones that will change based on the independent variable. Okay, so the independent variable is what you are changing or what changes on its own. The independent variable is what you're actually measuring in your experiment. So in this case, over time, the volume of this gas is increasing. So you're measuring, basically you're keeping track of the time as it's continuously going on, and then you're measuring the volume of the gas. Okay. Now, your dependent variable is always graphed on the y-axis. So the way to remember that is dry mix. So dry stands for dependent variable, or what's also known as the responding variable, is on the y-axis. Okay, mix is the manipulated variable or the independent variable on the x-axis. Now, a couple things when we get into graphs. I'm actually really kind of picky about them because if you don't do all of your labels, I have no idea what I'm looking at. So this graph is actually really good for showing all the different parts that you will need in your graphs. First, they have a title. Okay, and when we get into actually doing graphs, if you've never worked with graphs in Excel, I can show you how to do that. So don't worry about that part too much just yet. You just need to have your title, okay, which is a descriptive title. Basically, it tells you what you're comparing in the graph. So volume measured over time. So volume of a gas over time. Pretty simple. Then you have to have your axis titles, okay? So, and then units that these numbers are in, okay? So you see that they have the units on both. Now, if you have a straight line, so it doesn't curve like this, you'll also need to put the function, okay? Which, again, there's a really easy thing in Excel that does that for you. You don't have to worry about actually figuring any of that out. And so I'll show you how to do that when we get to that. But okay, so these line graphs are very good for showing the change in a dependent variable over time. Okay, again, time is your independent variable there. So, all right, next up we have bar graphs. So bar graphs are used when you're comparing similar data for several individual events or items. All right, so for an example, measuring the melting points of different metals. So if we look at this here, okay, it would take you just, a couple seconds at least to look through each of these numbers, each of these melting points, and figure out which one's the highest and which one's the lowest. Okay, but if we put that in a bar graph, it's pretty easy to see immediately. You've got iron has the highest melting point, lead has the lowest. Okay, and then if I had asked you just using just this chart, to put them in order from smallest to largest, okay, that would take you just a sec, right? But if you look at this, okay, you can say lead is the smallest, then you've got aluminum, silver, gold, and iron. Instant. Okay, so that's why these bar graphs are so useful. Now you'll notice metal does not have a unit, okay, because it's not an actual number measurement. This case, they have their labels on each individual bar. Okay, so, all right, last type of graph that we're going to talk about is the pie graph. So pie graphs are used when you're showing data that's part of a whole. Okay, so you've got your whole chart, and then it's split into little pieces. So the data is usually shown as percentages. So here's an example here, just looking at the textile fabric composition of the jacket here. Okay, you can see pretty easily that it's mostly nylon. There's a little bit of spandex, so there's a little bit of stretch to it, and then it's also partially polyester. Okay, so it's great to see as a whole the different composition of it. All right, so that is the end of this chapter. Okay, so just make sure that you're getting all of your assessments turned in, that you're getting a 7 or higher on each of them, and then also make sure you're getting your homeworks in. Okay,